Hello everyone and welcome to this session of Blockchain Tutorial Part 1. My name is Saurabh and I am part of the Simplilearn team. So let's get started and understand what's in it for us today. So let's take an hypothesis. In a city not so far away, somebody was up to something bad. So there is a hacker who hates the bank, who wants to steal the money of all the people lying in the bank. Now, here's why I hate them even more. What are the nuances and the problem areas of the banking system? The banking system has higher transactional and international transfer costs. A lot of documentation is required for setting up of an account, for opening an account and onboarding a customer. And the banking system is not always accessible. It's not 24/7. It's closed on banking holidays and it has other limitations also like transfer limits in a day and you can't transfer X amount within a stipulated time. Now, banks in such an ecosystem acts as a center point of failure. It is a centralized based system which is prone to failure from a centralized point of view. So if the bank fails, all the transactions will come to an halt which are dependent on the bank. Now let's see what happens if the hacker is able to get into the banking system and hacks the bank. All the investors or the people associated with the bank, the information associated with them will get corrupted, will get jeopardized, and it can lead to huge losses to the bank and to the individuals. And all this can happen with a click of a button. It's as simple as that. So once a hacker has access to the system, he can manipulate the system, compromise the information, share it with the parties which are not supposed to have that information, and lot can go wrong. Though the hackers can be caught, right? It is possible through cyber security and various means. But once the information is compromised, it is very difficult to roll that back. And that's why we need more secure systems and systems which are not dependent on a centralized authority, which work in a more decentralized fashion, thereby making it hack proof plus lowering the transaction cost also. Now, this incident, of course, will catch the bank manager's attention. Now, he will go to his advisors and want to make sure this does not happen again. So, the technology people, the advisors will make sure that this does not happen. But what is the remedy? So, the remedy is setting up a blockchain. Now, of course, the manager who's looking into the banking functions might not be aware of the technology and what benefits blockchain bring onto the table in order to prevent such an incident. So that's what we are here for. We will learn before we go and understand what can blockchain actually achieve for us. So we will understand today what is blockchain, the Bitcoin story, the features of blockchain like public distributed ledger, the hashing encryption, the proof of work consensus algorithm, and the concept of mining. And then we will cover up a use case where how blockchain can be used for banking operations. Now, what is blockchain? Blockchain is a list of records called blocks which stores data publicly and in a chronological order. And the entire information is persisted using cryptography. It is secured using cryptography. So cryptography ensures that the privacy of the user is maintained and data cannot be altered. Information on a blockchain network is not controlled by a centralized authority. So unlike modern financial institutions, nobody controls the data within a blockchain. The data is maintained by the participants of the network and they are the democratic authority in order to approve any transaction which can happen on a blockchain network. Access to anyone on the network. So a typical blockchain network is a public blockchain. So as long as you have access to the network, you have access to the data within the blockchain. If you are a participant on the blockchain network, you will have the same copy of the ledger which all other participants have. So therefore, every participant on the network has the same copy of the data. So everyone in the network has a copy of the blockchain data, which is used for ensuring that data remains untampered. So even if one node or data on one particular participant computer gets corrupted, the other participants will come to know immediately that this particular instance or node has gone corrupted and they will rectify it as soon as possible. So basically, the question is this the same technology that Bitcoin works on? And the answer is yes. Bitcoin could not have been possible without blockchain. So we will understand how Bitcoin adopted blockchain in order to reach to its journey today. So Bitcoin was introduced in 2009 by someone or a group of people known as Satoshi Nakamoto. It aimed to solve the problem faced by fiat currencies with the help of blockchain technology. Now, as of today in 2018, there are more than 1600 cryptocurrencies that follow the concepts of Bitcoin and blockchain. For example, the other popular cryptocurrencies are like Ethereum, Litecoin, Dash, Ripple, and many more. Now let me explain how a Bitcoin transaction works. The sender transmits the transaction details worldwide. Basically, whenever a sender has to do a transaction, he has to send Bitcoins to a receiver. He will submit the transaction on the public blockchain network of Bitcoin and transmit it. Now, verification to authenticate users, it is done by the miners around the world. So basically, there are specific participants in the Bitcoin network which are called as miners, whose job is to verify the authenticity of the sender and the receiver, and also validate whether the sender has the right amount of balance for the Bitcoin which he is trying to send to the receiver, and ensuring that the sanity of the underlying blockchain network to the Bitcoin remains correct and not get corrupted. So once the miner has authenticated the transaction, verified all the parameters, the transaction is added to a block, and then that block is made part of the main blockchain. Once the block is added to the blockchain, the money, the transactions which were associated in the block then gets executed. Money is deducted from the sender's wallet and is added to the receiver wallet thereby. Once the transaction is completed, the block is added and the ledger across all the nodes are updated. Each and every participant ledger copy is updated with that particular block which has been added in the blockchain. So therefore, all the participants have the same copy of the information. Now, so what makes blockchain special? Now, these are the special 4 features of blockchain which we're going to talk about in detail. It is a public distributed ledger. It works using a hashing encryption. Each and every block has a hash value, which is the digital signature of the block. All the transactions are approved and verified on the blockchain network using proof of work consensus algorithm. And the blockchain network utilizes the resources of the miners who are there to validate the transaction, and the miners, in lieu of investing in their resources and validating the transactions, get rewards in terms of Bitcoin, and that process is called mining. Now, public distributed ledger. So let's imagine 4 friends sharing a particular document amongst each other, correct? Now, if there was only a single copy of that document and one of them altered the data, it may go unnoticed. However, the outcome would be different if each one of them had a copy of the data. So therefore, if each and every participant has the same copy of the data, even if one of them changed the data, the others would find that the data does not match with their own. So blockchain works in a similar fashion. The data within a blockchain is accessible to everyone. So with this, as long as you are part of the network, you could access the entire history of transactions that have taken place since the blockchain was created, since inception. And the first block in any blockchain is called the Genesis block. So from the Genesis block to the current block, you will have the access to the entire chain. Any additions to blockchain have to be approved by the participant users in the blockchain network. So a majority of the members within the network have to approve of any additions to the blockchain. This is the public part of the ledger, and this is important because any additions made to the blockchain are permanent and are immutable. So immutable transactions are the transactions which cannot be altered. Once registered, they cannot be modified and are available for audit and verification 24/7. So this means that each and every detail is recorded, and any alterations can be detected by verifying it against everyone's personal version of the blockchain. So if someone's tried to modify a data on a block on a particular node, then the other ledgers which are having the same information will come to know that someone has modified data on a one particular node, and they will try to rectify it. And the fourth property, no central authority is controlling the working of this blockchain network. It is a decentralized network. So this is where being decentralized helps. Everyone has a copy of the blockchain, which means there is no central point of failure. There is a single source of truth. Even if things go wrong, the data can be recovered. If one node goes wrong, the data can be recovered from other nodes. But what about security? How is privacy maintained if everything is so public? And here hashing encryptions comes into picture. It takes care of that. So now we will talk about the second feature, which is hashing encryption. But to understand hashing encryption, we need to understand the contents. What are the contents of a block? So a block in a blockchain is like a container that holds aggregated transactions. It contains certain set of transactions. So we will see what all things construct a particular block. So a block has two parts. It has a header and it has the second part is the transaction details. It is the set of transactions which are aggregated in this block. Now the header has following set of attributes. It has the block version number. It has the hash of the previous block to which it is linked, the current timestamp, the timestamp at which the block was verified, the nonce, we will see what is the attribute, what is the meaning of nonce, and the target value. Now, the transaction details are nothing but the example which we talked about earlier. It is the transaction which the sender and receiver are sharing. The sender is trying to send certain amount of Bitcoin from his account to the receiver's account. Now, it is represented in the form of a 256-bit hash value in the header called as Merkle root or the hash root. So basically, the Merkle root is the hash of all the transactions structured in a Merkle tree called binary tree. It's a kind of a binary tree, and the hash value of the root node of the Merkle tree is called the Merkle root hash. So the transaction details of a block are contained in the header in a hex value known as Merkle root. The Merkle root can be calculated in this way. So basically, the list of transaction, each transaction is passed through a hashing algorithm. Then all the hashes of the transactions are paired and then again passed through another hashing algorithm until only one value remains, and which will be the root. Now let me tell you how a hash function works. Blockchain utilizes a hash function to perform cryptography. Data from a data set of random size is sent as input to a hashing function to get an encrypted value of fixed size, and that is the feature of any hashing function. So some unique properties of hashing function are these are deterministic. The same input will always produce the same hash output. Small changes in the data can drastically change the output. Basically, any small change to the input produces an output that's drastically different from its previous obtained outputs. It can be computed easily. The output values can be obtained without a whole lot of calculation, and hashing functions are one-way functions. Basically, you won't be able to determine the input based on the output value. So you can't do the reverse calculation. Now let's go back to our block we were talking about earlier. So as we were discussing, what are the features in the header? The previous hash is the resultant hash of the previous block in the blockchain. And this is the way two blocks are linked together. Now transaction details, these are used to provide details about the sender, receiver, and how much money they want to exchange between them. And this is a list of transactions, and they are structured in a Merkle tree, and the hash of the Merkle root is put in the header. Nonce is a value that is varied to create a unique hash address of the block, which should be less than the target hash value. So this is the structure of the header. It has a block version number, basically the sequence number of the block. It has the hash of the previous block, the timestamp when the block was mined and verified, the nonce value. The header is then, this entire header is then passed through a hashing algorithm. In the case of a Bitcoin network, it is SHA-256, and a hash value is generated. And now this hash value becomes the hash value of the block. Now this value is a 256-bit value that is used to uniquely identify the particular block. So SHA-256 ensures that alterations to data can be easily detected. So for example, consider these two blocks in the blockchain. They have a similar structure and definitely different hash values. Now if someone alters the transaction details in the first block, the corresponding hash value of the block would change too. Now the values of hash value of the first block and the previous hash value of the other block will not match. Basically, the block subsequent to the hacked block will get delinked. Now this will raise an alarm among the users, informing them that data alteration has taken place. The users will then be able to flag the block, so the alteration can be easily identified and rectified immediately. To ensure security, blockchains also include digital signatures. These ensure that the message comes from the right identity, right person, and that the message is not tampered with. Users are provided their own private and public key. So whenever a user onboard a public blockchain, he is provided a pair of public and private key. Now private key is used by the user to control her own account. This is kept as a secret by the user. So basically it's like his own password. And public key is used to identify the user on the network. This is shared by the user along with the transaction on the network for others to verify. So these are the steps involved in creating and authenticating a digital signature. So at the sender side, the message to be transmitted is passed through the hashing algorithm. In this case of Bitcoin, it is SHA-256, and the hash is generated, plus the private key is used to generate a digital signature. Now this output is passed through a signature algorithm along with the user's private key to create a digital signature. Now during the transmission, the user's message, their digital fingerprint, which was generated in the previous step, plus the public key are transmitted across the network. So these three things are published on the network for the validators, for the miners to use and verify the authenticity of the sender. Now at the receiver's end, first the message is passed through a hashing algorithm. Now at the same time, the sender's public key and his or her digital signature are passed through a verification algorithm. Now both the functions will generate a hash. If both the hashes are compared and if they match, then the transaction and the identity of the sender is approved. Otherwise, it is rejected. So basically, this is the process by comparing the hash values to authenticate the identity of the sender. Now, what about the people who verify these transactions, and how do they actually do it? So remember that one field in the block header called nonce, that becomes very important in order to verify the transaction. So now we will talk about the third feature, which is the proof of work consensus algorithm. So proof of work involves people around the world, the participants in the network called miners, competing to be the first one to add a block to the blockchain. And in lieu of this, they will be rewarded. There are competing miners around the world. They are trying to solve a mathematical puzzle to be the first one to be rewarded and to add a block to the blockchain. So this is the reward. So thereby they invest in the computing power, they invest in the resources in order to mine and validate a transaction to get that reward. Now, what is the mathematical puzzle? So basically they need to find a hash value that satisfies certain predefined conditions. Now, in order to find the hash value, they will use nonce. So this target hash value is decided months in advance for every block. The miners keep variating the nonce value to find out an output that falls within the target requirement. So they keep on generating a hash value using the nonce, and if it is less than the target, the hash value is accepted, and if it is greater, then the hash value is rejected. The miner's effort is not considered valid. Now, a miner transmits across the world that he has found a nonce that satisfies the target requirement as soon as he finds it. And thanks to the hashing algorithm used, this claim can be easily verified by others. So basically, the proof of work algorithm, it is very hard to generate the nonce and get the hash value, but it is very easy to verify the transaction by the other miners. So that's a whole lot of work. What a miner's payoff is. So for all his or her hard work, they get paid in the bitcoins, and this is the only way the bitcoins get added to the network. Sometimes they get other forms of remuneration as well, and this is the concept of mining. So the entire process, when the miner has done the proof of work consensus, they are rewarded, and this is called as mining. So mining is the process of adding a block to the blockchain. This miner is the first person who found a nonce value that fell within the target requirement, right? Now for doing this, the miner is rewarded. As of today, on the Bitcoin network, a miner is paid 12.5 Bitcoins for adding a block onto the blockchain. But the reward a miner gets reduced by half every 4 years. So when the fourth year will approach, for the threshold, the Bitcoin reward will go down to 6.25 Bitcoins. And the miners also get the sum of all the transaction fees for that particular block. So the 12.5 Bitcoin reward is justified as mining is a very expensive process. It has a heavy toll on electricity, computing power, and other resources on which the miner has invested. Now we will take a look at the use cases where blockchain is applicable in banks. So we have been incorporating a program where banks can validate user identity. As of now, a user needs to do the process over and over again in each bank. He has to go and prove the identity in each bank. Is there a way we can ease the process with blockchain? And the answer is yes, we can. We will be using Truffle, Ethereum, Ganache, and smart contracts, all of these blockchain technology ecosystem to make it work. And welcome to this demo for how to build your KYC blockchain application. Now I'm gonna show you all the steps required to deploy your KYC application, what all components are to be developed, and how to go about deploying and testing your application. So primarily this KYC application will allow banks to do a decentralized KYC of the customers which come to their banks. So in the demo we will see when a customer walks into the initiating bank, will do the KYC for a customer, enter its details and verify it. And if any subsequent bank wants to use the KYC done by another bank, he or she needs to take the permission of the customer, and then you can use the same KYC for verification. So we will see how can we do that. So just to start off with, we have developed a KYC solidity contract which has all the necessary functions in order to do the actions required for doing a KYC of a particular entity by the bank. Now once this contract is ready, we will be placing it in our sample truffle package. So this is my truffle package, and in this I have the contracts folder. In the contracts folder I have kept my kyc.sol file. Now in the command prompt I will compile my contracts. We can ignore the warnings. So here is my Ganache client which I have just started, and in my Ganache client, as you can see, it is running on port 8545 and it has already given me 10 accounts pre-funded with 100 ether. Now I had already mentioned that my truffle is connected to localhost 8545. So now when I'll do my truffle migrate command, it will connect to my Ganache and deploy my KYC contract. So now I can go to Truffle console, and for me it's very important to see at which particular address my Solidity contract has been deployed. I'll copy it, and in my UI code under root.js contract details.js, I will make the change of this address where my contract has now been deployed. Now, after doing these steps, my application is ready to interact with my Solidity contract, which is being deployed on my local blockchain network. Now, as you can see, when I deployed the contract, this is my primary account from which the ethers were deducted in order to deploy the contract. Now there are certain steps in order to get the application up and running. So first we need to sign up the banks. So suppose I say bank 1 and the password should be the first address of the bank. So basically we are associating one bank with one account which we have on our Ethereum network. So we will sign up. Now bank 1 is successfully registered. So now in order to log in, I can check. Now bank 1, I have logged in. Now I need to add a KYC for a particular customer. Now after filling the basic details, I will create the customer, and the username I have kept is customer1. Ideally, this is the unique identity of the customer. It can be any social security number or the Aadhaar number or any unique identity which is attached to the customer or the email ID and can be used as the unique identifier for the customer. Now, once customer profile is successfully created, we need to log in as a customer to allow this bank to see the KYC details. Now, suppose if I say customer 1 and search it, it is saying access denied and take the permission from customer to proceed. So before the bank can do the KYC complete, the customer need to approve it. So I am creating the credentials for the customer. Now customer can see his details, whatever were filled by bank 1, and he can see that there is a request from bank 1 to allow to view his KYC. Now before we allow, I will also create another bank, bank 2, and associate it with my another address and try to log in with it. Now bank 2 is also logged in. Now bank 2 has not done the original KYC, right? But it is trying to look up and its access is also denied. So it needs to explicitly take permission. So the bank will take explicit request from the customer. So now the customer has request from bank 1 and bank 2 for the KYC. It is up to the customer whether he or she wants to allow and deny the KYC request. After the permission has been granted, then only the banks can be able to view the KYC. So if I say bank 1 allow and bank 2 deny, now all the requests are done from the queue. So bank 1 was allowed and bank 2 was denied. So if I again log in with bank 1 and the password is my first address, view KYC customer 1. So here it is, the bank 1 is able to see the details. Now if I log in as bank 2 and give password and try to see it is saying permission denied. So let's ask bank 2 to again request. Now bank 2 is now again requesting and now this time it allows. Now bank 2 can see the details. So all these transactions in the backend are happening on the blockchain network, which is interfacing with the contract through its subsequent methods. Now the primary details of the contract are in the contract details.javascript, where we have to provide the address at which the contract was deployed, the ABI file, the ABI. So you can get the ABI at here. This is the ABI and you can paste it here. And this is the binary data, which has to be pasted over here. So the binary data can be fetched from Remix. This is the binary data for the contract, which has to be copied and pasted over here. Now with these essential inputs provided, our application allows us to interact in a decentralized fashion to access the KYC records of a particular customer. Now we can modify the details also, and we can add a new customer again. So this is a basic demo of how a typical KYC application works in a banking environment. Am I a blockchain expert now? Not quite yet. There's a lot of more information you need to learn. We'll go to that later. Now let's do a quick recap. So what have we learned today? We learned what is blockchain, the Bitcoin story. We understood the public distributed ledger concept, hash encryption, the proof of work consensus algorithm, the concept of mining, and the use case of know your customer, blockchain, decentralized application, which is used in banks, and the use case of blockchain in banks. I hope you all had a great learning session, and I'll meet you in my next session. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.